Welcome again. In this video, we will speak about Chapter 2, Control Structures. To start with, we will introduce the concept of algorithms. Then, we will speak a bit about pseudocode, control structures, such as if that we ended by in chapter 1. We said something about if statement. Now we will further look into if else syntax, then the while loop, and finally the for loop. To start with, we will explain the concept of an algorithm. An algorithm is nothing but ordered steps that normally, if you undertake, will solve a problem. So, for example, if you have a set of actions and orders to be ordered in such a way that to solve a problem, say for example, in page 62, the author gave this example of rise and shine algorithm, where he said that steps are: number 1, get out of bed; number 2, take off pajamas; number 3, take a shower; number 4, get dressed; and 5, eat breakfast; and 6, carpool to work. If, for example, you switch taking shower after getting dressed, you'll arrive to your work with having wet water on your dress. So that wouldn't work fine with you. So algorithms is a set of actions that you need to order them in such a way that you can have your task done properly. Now, if you think of our last example, we said that we would like to ask the user to write down the temperature, and based on his input, we would decide to give him a proper feedback. So, number 1, maybe a welcome message. Then number 2, ask the user for the temperature. Number 3, respond to the user based on the temperature. Now, these are the main 3 tasks that we will undertake to build out our program. So this is an algorithm. These are the actions and steps that in this order will produce a useful task. So if I switch, for example, this one and put it at the beginning, it will be useless to respond without having knowing the temperature value from the user. Now, number 3 can be further explained in more details. So, for example, I can say A, if temperature is greater than 50, then say it's very hot. B, if temperature is in between 50 and say 25, I don't remember, 25, I think 35, then say nice weather, nice day. C, if the temperature is below zero, then say it is cold, and so on. So now to transfer this into program, we just see each and every line here. So welcome message, this can be transferred into a cout statement in C++. Ask the user for the temp, this can be translated into cin after we ask him for. So there are two steps here. Two steps here. This could be, for example, a display what, okay, please enter the temp, and then b read temp from the user. So step 2 has two parts. One, I'm gonna see out this message so the user knows that he should enter a temperature value. Then this is cin. Now to do this, if I'm gonna write a program, it would be something like this. Now after int main, I would like I like something like this: cout welcome to my first program /n to give a new line. Then cout please enter a temperature, or the temperature. I don't need /n here, so that cin will be exactly in the same. Now please notice that I reverse the direction to input temp, but temp is not defined yet, so I have to define it as an integer. Now once I have temp defined, then I'm done with this step here. Respond to the user based on the temperature. So I have, if temperature is greater than 50, then I should write it here, if, then parenthesis, temp greater than 50, then it says here, then say it's very hot. Fine. So I'm gonna write cout, that will display it on the screen. It's very hot. I'm done with this one. Now if temp is less than no, sorry, if to write this down, let me copy it to be exactly, and, or should it be or? If I have this part here, temp is greater than 25, and because these are intersecting, temp is less than 35, so I should write and. So I have and here, then I should copy this part here, because C++ I cannot write them two conditions together in this way. I have to break them in parts. Then I should write nice day. Okay, display nice day. Fine. I like to put new line every end of each sentence. Now next, if, then I have this fellow here, put it down here, cout, oh yeah, it's cold, /n. I'm done. Return 0. That's it. I'll just close the brackets, and then I'm done to copy this and take it to a compiler. I'm here, have a new project, project, console, fine, temp 1. So I just paste it here, I don't need all this. I'll keep the using namespace. I'll keep include thing. So I just paste it here. Should it be like this? Fine. Now compile and run. Temp1. Good. So welcome to my first program. Please enter the temp. If it's like 55. Oh, it didn't stop. So I need to have it stop and wait for me to read the output. So this is what I've removed a few seconds ago. So system, I think pause. Now, if I execute again, having different value entered, I have a nice day. So it's working. So this is how we think of a program, by first writing down what is to be done, breaking down our thoughts into steps that is organized as tasks in certain steps. Once it is done, it will produce an output. Then we transfer these English words, which we sometimes call pseudocode. Pseudocode means it's like it's an artificial informal language that helps programmers to develop an algorithm. So it's kind of steps, organized steps that will give us a way to organize our thoughts. Think of it as an intermediate process between our normal speech and language into the computer program. So this is, in such a way, is closer to the way we programmed it here in this code. Now there's another way to just write out our thoughts. It's called the flowchart. So flowchart, we can write different things using flowcharts. So for example, if we read this, lamp doesn't work, then lamp, is it plugged in? If no, just plug in lamp. If yes, then bulb burned out. If it yes, just replace the bulb. Otherwise, have yourself a new lamp. We can have these drawings by having these basic flowchart symbols. So we started, this is a terminator. We start and end using this one here. So as we have here, we started with this one and we ended here. These are terminators, we end. So these are the decision that we finalize our program into. Then input output are used with this shape here. Squares are for processes, and these diamond shapes are for decisions. Circles are for connectors. If you have a long flowchart, you can hook one and just continue on a following page. So we could have an example. This is a pseudocode, something similar to what we wrote few seconds ago, but this time it's gonna read x, y, z and then compute the sum, call it s, as x plus y plus z, and compute the average, call it a, as s, which is the sum, divided by 3, this is all about average. Compute the product, which I'm going to call it p, as x times y times z. Then we write, which is nothing but displaying on the screen, the sum, the average, and the product. So having this, I can transfer it into a C++ code, or maybe if I feel it is easier for me to write it down as a flowchart, as I have it here. So I'm gonna start. So this is actually think of it as the main starting point, curly brackets, then read X, Y, and Z. So since we are reading or think anything from the keyboard, we put it in this shape here. Then this is for calculating the values of S, A, P. Then we are writing on the screen, so we use this shape, and finally we stopped. So flowchart and pseudocode are exactly the same. If you are a vision person, you can use this one. If you're kind of a person that find it easier to write down your thoughts, it would be easier for you to just write it in a pseudocode way before you type it as a program. Now these are logic operators that we've seen last lecture. This is equal, not equal, less than or equal, greater than or equal. And sometimes we can compare. For example, if we read A and B, then compare A and B. If A is less than B, then we go through the yes arrow. We go through this arrow here. So big equals B, since B is bigger. So we have a new variable here. I called it big, and another variable I call it small, and small will be A because it came through this arrow. If this is false, then it will go through this path here, and big will no longer be equal to B, but big will be A, because since it came through this pathway here, no means A was bigger, and hence I would like to grab that value into the variable big, and small will be B. And finally, whichever path the program took, it will at the end print the value of big and small, and both of them will have the bigger and the smaller value respectively. So this is another way of writing flowchart. We will see how to use the if-else in our program writing. So if I'm going to code this program here, I'll first of all ask the user. Now since we have big and small, A and B, let me, just before I forget, just have them all here. So I have A and B, big and small. Usually in C++ we write variables in small letters. You can have them big letter, but it's really a matter of convention. Now C out, I just give indication so that the user will know what he's going to expect to enter. So please enter two numbers. Fine. Now cin, I'm gonna have A and B entered by the user. It should be written like this. Actually, I can have C in A semicolon and C in B semicolon as a new line. This I can do, but also I can have them in a single line. So these are two ways to enter them in C++. There's always more than one way to write a single program. Now, having entered these two, let me go back and see the flowchart. So I've read A and B. Actually, I had here I wrote down something here that wasn't shown here just to make it user friendly. I wrote down please enter two numbers. It wasn't originally here, but I added to make it easier for the user. Now I have to add this one here, if. Now I'm gonna say here if A is less than B, have it A is less than B. If yes, then big equal B and small equal A. So let me write it down. If yes, then it's gonna execute whatever is preceded after the parentheses. So so big equals B. Since this is greater and it came here because this is true, then big, this value here is equal to B. Now, if I have two statements and I would like the if to execute two statements instead of one, I have to bind them into curly brackets. Otherwise, if I put, for example, small equals A, now these are not binded together. Both of these are not binded together, because the if statement, if this is true, will execute the first following statement. If this is false, it will skip only one following statement. So it's not gonna skip both of them. If you need to combine them both together, you need to put them in curly brackets. So this will give indication that this is a block, so it will either execute them together or skip them together. Now please, I would like to emphasize on this point. Please don't make this mistake. Never ever have writing the else the statement that's following the if statement. If you would like to have them both together combined, you should put these curly brackets, otherwise you are doing a big mistake. Now else, we have this else part, then now big equals A and small equals B. Finally, the last part here is I'm gonna write big and small. So let's see out the big number is big. See out the small number is small, and this will conclude our program. Let me have an L here. Let's execute. Please enter two numbers. So I have 5 and 10. The big number is 10. The small number is 5. Let me just change them and have 10 and 5. Still, the big number is 10. The small number is 5. Okay, let me try it. 99 and 3. So the big number is 99, the small number is 3, and so on. So it's working. Now let me just try to remove this these two and see what I have, just to make sure if I messed things up here or not. I'm gonna comment this one here, or let me show it in another example. Yeah, now if A is less than B, then big is B and small is A. let me change the full example and have another example just to show the if and else part here. Now int x equals 10 and y equals 5, then if x is less than y, which is not the case, then I'm gonna see out, then I have stars, then see out again, then I have these and percent, then I have see out here, then I have these pounds, and I would like to have a new line following each of these symbols to make things readable. Now let me explain what I have here. Now I wrote here if x is less than y, x is 10 and y is 5. So this is true or false. It's clearly this is false because 10 is not less than 5. So since it is not equal, since it is not satisfied, so it should skip the first statement following the if. So it should skip this one only. But sometimes you might think that it will skip both sentences. That is not true. We can check it now. So if I execute this one, it should print the ampersand and the pound sign. So if I execute here, I think I made a mistake here. Yeah, I should write here int again. See, it printed the ampersand and the pound. But if I combine them into a curly brackets, then execute, it will skip the full block. So I only have this pound sign, which means that it skipped the whole block. It skipped this whole thing here, and this is what we intended to do. So this will show the importance of having these curly brackets. Embraces our statement that we would like to either skip or have them executed once this is true or false. Actually, you need not have them on the same line. You can have them on different lines, and both while it's embraced by this curly brackets, then it will consider them as a block. So if I execute, it will still skip them both, even if they are not on the same line of the if statement. So please make sure that you have these curly brackets in right places, otherwise you'll screw up your program very easily, as I have it here in this example. So indentation makes no indication whatsoever to the reference of what this to whom this belongs to. Does it belong to the if statement, or is it after the if statement? This makes no difference. What makes difference is the curly brackets. One last thing here is, as a shortcut, you don't need to put int again. If you put a comma, so my mistake here was I put semicolon, which terminate the statement, but a comma will continue having to declare another variable, as I have it here, with an initial value of 5. So this will run exactly the same as before. So saying this, we conclude the use of if else. As we've seen, the if statement it will either execute or skip the following statement or block based on the truth value of whatever between the parentheses of the if statement. If I put an else part like this, then I should combine these together. If I put an else part, then now it will be exactly as I have it here. It will either execute this block of code or this block of code. So it will either execute this one or this one. So it has to execute one of these. So it will not execute them both together. Now, if I execute now, let's see what happens. See, it executed the pound. If I switch this around, then it will execute only the first part. See, so it skipped the second part because I have the else. See, let me see it again. So now it executed the first part because the if statement is now satisfied, so it will execute the first block and skip the second one. The second one means the first statement or block of statement following the else part. So this is why it skipped this one here. But without the else, then it will be as normal. It will either execute this or skip it. But in both cases, without the else, it will execute always this statement here because this statement is following the if statement. So if I execute, so now I have them all three together because the if statement was satisfied. If the if statement is not satisfied, it will skip the first block and always execute the second, no matter what is the value of this expression inside the parentheses. But in the case of else, then it will either execute this block here or this block here. I hope the concept of if and if else is clearly distinguished by this example. So this is to describe the differences between these two. Now, looping is another concept that we will see here. Now we've finished 2.3, 2.4 control structure, and we have in the book page 65. These are cute keywords that C++ have only these keywords, so it's not much. So the main reason we have them here that you should prevent using variables having these keywords. So it's not you cannot, for example, use a variable such as x, y, then maybe use int. So you cannot use int as a variable. So please keep your eyes on these keywords that are on page 65 and prevent yourself of using any of them as a variable in your code. Then we've done with 2.5 if selection structure and 2.6 the if else thing, and we are ready now to go for the loop structure. The loop structure is where you would like to have a certain code be repeated more than one time. Now to do that, I have to clean up this space here and have, for example, let's say int, say I consider it as a counter, equals say 1. Then I would say while I is less than 10, it will execute this code here inside this block. So it will keep executing whatever inside the block while I is less than 10. Now I is initialized by 1, so this makes it true at the beginning, and so I'm gonna see out the value of I just to keep my eyes on it, and L. Then doing that, it will keep printing. It will keep printing 1 1 1 1 1 all the way. Without and L, it will fill the screen with number 1, because it will keep executing this. Let me show you here. See out. What happened? Control C. Did I close the? Oh yeah. So Control C. So if I execute this one here, see, it will fill and keep filling the screen. I'll Control C just to break it, and so it's keep filling it with 1 1 1 all the way, because I is never changed. It's initialized by 1 and never changed. But if inside the block I'm adding 1 to I every time, so I'm doing like this: I equals I plus 1. Now every time it executes, now see out, it will print, the first time it will print 1, then it will execute the statement here, which will add 1 plus 1 means 2. The new number 2 will be replaced by the old value of I, because this is what assignments is all about. So the new value of I will be 2. Now this brings me to the end of this block. I cannot exit this block unless this condition is false, which means I have to check it. Now I, the new I is 2. Is it less than 10? This is true. 2 is definitely less than 10. So I cannot exit, because while statement will keep holding me till this expression is false. So this is what is while is all about. It's while the condition holds, execute this block. So while I is less than 10, keep executing this block. Now I is 2, so I have to execute this again, which means it will print 2. Let me have and L to have each number printed on a different line, new line. Now I will execute this one here. It will add 1 to the value of 2, which makes it 3. Then I'm back here to check the condition. I'm still less than 10, which takes me back into the block and prints the number 3. Add 1 to it, now which takes me to 4. Now I check 4 with this condition. It doesn't allow me to exit still, and all the way till I reach 10. Then 10 is not less than 10. 10 is equal to 10. So this will be false, and I'll never print the value 10, because when I is 10, this was false, and I wasn't allowed to enter to the block anymore, and I'm in this system pause, and that's it. It's done. So let's execute here and see what happens. See? So I have from 1 up to 9. So this is what happened when I execute this code here. So this is all I have to know about while statement. The while structure is always written as so. I write while, and then I have parentheses. Whatever inside the parentheses, if it's hold, means if it's true, then I will keep executing whatever inside the following statement or block of statements. the same thing to be said with the if statement. It will hold the following either statement or block of statements. And usually we need to have it a block of statement, because if it's a variable that I'm gonna increment, unless I increment this one, it will never change and I will always be less than 10, and we are in this endless loop that we cannot exit. It will go to infinity. So we have to make sure that the counter is always incremented, decremented, whatever our situation is. We must always make sure that we have initialized that variable with an initial value. Now we are ready to make nice programs, for example, to calculate, for example, the summation of, let's say, 1 up to 100, for example. If I would like to add 1 plus 2 plus 3 plus 4 plus 5 all the way to 100, I would like to know what is the value of this thing here. Let me comment this because this is not a code. Then I started with 1 and put this 101, or I can make it less than or equal. Why do I need to make it less than or equal? Why is not less than sufficient? Do you know the answer? Yes, because if it's only like this, then it will add them all the way to 99, because 100 is not less than 100. So we have to do it like this. Then try to have 5 minutes and solve it by yourself before you continue this video. So pause it here and try to give yourself 5 minutes, and then turn back here, click the play button and see the remaining of this video. Yes, I hope you solved it. Now, if you solved it, please check it with this solution. Now, if I am to add 1 plus 2 plus 3 plus 4 all the way to 100, if I'm to do it in my brain, I cannot at a glance know the answer, but I do it incrementally. For example, I do it by my head. 1 plus 2, this is on 3, yes, and then having this, I replace it with 3. Then 3 plus 3 is 6, so I replace this with 6. Then 6 plus 4, this is 10. I replace it with 10. Then 10 plus 5. See, every time I'm adding a new value to this current value that's being calculated in my head. So this one is the current result. So if I call it, for example, the sum, initially it was 0, because I cannot work with an uninitialized value. So sum equals 0. Now sum, every time sum equals sum plus what? Plus I, because I is the value that is every time incremented by 1. The first time it was 1, then 2, then 3, and every time I'm adding it to sum. Is it enough? No, because I need to increment I. Otherwise, I will remain at 1, and this will be an infinite loop, because always 1 is less than or equals to 100, and this loop will never end, and it will just keep adding sum to I indefinitely. So I have to put here I equals I plus 1. This will finish up the program. Yeah, I left something here. After we finish the loop, I should, if I'm working with a nice loop procedure, then after we finish, we have to print something so the user would know the result. Otherwise, it's useless. The sum is, and I just print out the sum. and have and L to make it readable. Execute 5050. If you try it yourself, you'll get the same result. Even if you try it by hand, I can guarantee you'll get the same result. The sum is 5050. Now, so this will add up our loop. Let me show you some shortcuts here. Instead of writing I equals I plus 1, there's a shorthand for it, I plus plus. So this will add 1 to I every time. There's if you ask me, is there a shorthand for this one here? Yes, there's a shorthand. Sum equals sum plus I. The shorthand for it is sum plus equals I. Sum plus equals I. Same thing if I say sum minus equal I is equivalent to sum equals sum minus I. And we go all the way. Let me show you here something. Now, I plus plus, this is equivalent to I equals I plus 1. Now, I minus minus is equivalent to I equals I minus 1. Now, I plus equals, say, 3, this is equivalent to I equals I plus 3. Now, I minus equals 3, this is equivalent to I equals I minus 3. Now, I times equals 3, this is equivalent to I equals I times 3. Now, I divide equals 3, this is equivalent to I equals I divided by 3, and so on. So these are shorthands to write them in. Now, there are some tricks here. We also have, for example, instead of I plus plus, I can have plus plus I. Now, if these are on standalone lines, they act exactly the same. But if they are within a context of other equation, then they act differently. Now let me show you an example. For example, if I say, for example, cout, and then I'm gonna print I plus plus, then it will print the current value of I, then it will add 1 to it. But if I say, for example, instead of that, I write it down as plus plus I, then it will first add 1 to the value of the variable I, and then it will print it on the screen. Okay, just to remember, see who came first from left to right. If you see the add, the plus sign, if you see it came first, then add it first, then apply the value after the addition. If you see the variable first and then the plus plus, then use that variable in your expression and do the addition lately after you finish that expression. Let me show you an example. Now let me clean up everything here. Back to a new code, a clean new main. Now, int I equals 10. Now, cout, I'm gonna print I plus plus. Then, I like to put new line here, and L. Then I'm gonna cout I. Now, in the second line, I did not add anything to I just printed the value I. Let me stop this for a moment just to print this one here. If I execute, you might think it's gonna print 11 because I added 1 to it, but actually since I've seen the variable first, then it will print the value of the variable before adding to it, and then it will add to it. So let's Let's see what happens. It should give me 10, which is reasonable. That match our description, because we said it's gonna print it first and then add to it. To make sure that it has been added, I just printed this I here, just to make sure that what is the value of I after executing this line here. So it should be given to me 11. So see, 10, then I have 11. Let me write it down here as and see, so we have 10 and then 11, which means it is done. Now if I just put it the other way around, see, now see what happens. It's 11 11. This means it has been changed first before it printed it. So this will conclude our experiment here of the difference between ++i and I++. Always make sure you have the right orientation whenever you use them. I hope this introduction to looping was helpful, and we are left with one final part about the for loop that we will explain shortly after this break.